Hello everyone, this video I explain some questions from practice exam 3, and one of the quantum numbers are very good. Okay, so pay attention and let's get into it. Okay, so for question number 18, okay, so if you look at it, it's about valence electrons and core electrons. Okay, so then let's look into, right, so quite straightforward. Let's see which statement is going to be true. Okay, so sulfur. Okay, remember valence electron for main group elements that equals to their group number. Okay, so sulfur is from 6A group. Okay, 6A is from 16, but we're counting as 6A. We're counting that way. Okay, so then it has 6 valence electrons, okay, not 16. It has 16 electrons, but only 6 valence electrons. The outermost shell only has 6. And then for bromine, okay, so it says has 28 core electrons. Is that true? So let's find out. Okay, so bromine from 7 groups, 7A group, so has 7 valence electrons. And then in total, you look at periodic has 35 electrons. Okay, so 35 minus 7 will be 28 electron, and then those electrons are called core electrons. Okay, so then again, this statement is true. So 2 is good. Okay, and then the next one for NH for ammonium ion, how many valence electrons? You go, it's not a single element, but we're just gonna add them up, okay, and deal with whatever the charge we have. Okay, so for ammonium ion, for nitrogen from 5A group, so have 5 valence electrons, hydrogen from 1. It doesn't from 1A group, but it does have 1 valence electron. So 1 times 4 has a positive charge, means lose an electron, so minus 1. So actually has 8 valence electrons, 10 is wrong. Okay, and then next one, so that's wrong, okay. And then for cesium, so from I group has 1 valence electrons, that's good. SF5 minus, then similar logic. Okay, so let's just simply add them up. Okay, 6 from sulfur, right? 6A group, 6 fluorine 7A group times 5 minus 1 means plus 1. Okay, you do this calculation, we'll get 42. Okay, so then that's correct. The last one, neutral alkaline earth metal, which is talking about 2A group. Okay, so for the main group, remember it doesn't include D. Okay, so it's in either S and ST. Okay, and so that's what we're wrong for that choice. Okay, so then so the choice, that's why it's 2, 4, and 5. Okay, this is about understanding of valence electrons, core electrons, quite straightforward. Okay, so the next question is very good question. Okay, so 27. Okay, so now see, this is really, you need to understand about your quantum numbers, then you'll be able to do this type of question. Okay, so now let's look into, I'm going to explain each choice. Okay, so let's see choice A. That's a correct choice, but let's see why it's correct. Okay, so for ground state chlorine atom, okay, so let's start to draw its electron configuration. That's what we need to understand, right? Okay, so or to do our observations or find out if this answer is true. Okay, so that's electron configuration, and then it's saying 3 electron will have quantum number m sub L equals to 1. Okay, you go, what does that mean? What does that mean? Okay, m sub L is talking about orientations. Okay, so this orientation m sub L value equals to 1. You go, what does this mean? What does this mean is that 1 m sub L will equals to, can have the possibility equals to 0. Okay, so then think about, if we have L equals to 0, m sub L just can only equals to 0. That's it. Okay, so then, which means if you talk about s orbitals, you can now have m sub L equals to 1, right? Okay, and then if you talk about L equals to 1, that's p orbitals, m sub L can equals to -1, 0, and 1. You go, oh, look, I have a situation is m sub L equals to 1. Then accordingly, you probably also realize if you're talking about d orbitals, m sub L, that's just a comma, that looks weird. Okay, and m sub L equals to what? -2, -1, 0, 1, and 2. Look, there's another 1 that our m sub L value can equal to 1. Okay, so then accordingly, from P, D, F, all of this, we'll have the orientation we can use m sub L equals to 1 is value to describe. Okay, so now you look at this choice. We're looking into chlorine atom. Okay, so do I need to look at s orbitals? No, right? It doesn't have m sub L equals to 1 that situation. So you just need to look at those 2 p orbitals. Okay, then what else the question is asking? Well, so we have 3 electrons have quantum number m sub L equals to 1. You go, how only 3? Look, I have 11. Do all those 11 have that? Okay, so again, now requires you to understand your orbitals. Okay, so that p, that 2p, as we said, on the second energy level, as long as p orbitals allow, how many p's we can have? 3 of p orbitals, because I'm going to stretch it out. This is actually a 2p, 2p, another 2p. Okay, and then when we talk about m sub L value by convention, we always start -1, 0, 1. Okay, so this is matching with m sub L equals to 1. This is matching with m sub L equals 0. This is matching with m sub L equals to 1. That's what we're looking for. Okay, so do you need to look at the first 2? Not really, but then let's see how the electrons are. I have 6 electrons. How do I assign them? We're gonna do 1 on each orbital first, then start to pair up. Okay, and I do have 6, so it's all fulfilled. Okay, so the next one that is. So how many electrons we are really looking? We're really just looking for m sub L equals to 1. Right? That's what we're looking for. We're only looking at this. Those we don't care. So that's 2 electrons. Then same logic you probably understand over here, right? So that 3p as p orbitals allowed. On the third energy level, I just have p, but now it's 3p because that's higher energy level. 3 of 3p. Earlier was 2 of 2, I mean 3 of 2p. Okay, so now it's 3 of 3p. Okay, so then I have 5 electrons. How before we go there, we also should remember this m sub L equals -1, 0, and 1. Do we care about the first 2? No, right? We only care about, that's what we're looking for. One more time, the question mentioning m sub L equals 1. So I'm only looking for the last one. So that when I have 5 electrons, how I'm gonna assign them. So 1 on each orbital first, then start to pair up. I only have 5. So that last orbital, last p orbital, m sub L equals 1, I only have 1 electron goes there. Okay, so now therefore, my final answer, right? Just that and that. That's it. Okay, so then that's why I have 3 electrons have quantum number which has m sub L equals to 1. Then that's about that question. So that's true. Okay, so that's for that. Then let's look at choice B. Okay, so for choice B, it's saying when n equals 5, L equals to 1, the maximum number of electrons can be found on those orbitals is 2. Okay, so then you have to understand n equals to 5, L equals to 1. This is matching with p orbitals. Okay, so now we don't have other requirements. Okay, right in general, when we talk about p orbitals, how many of that p orbitals gonna have is determined by the m sub L value. M sub L value equals to what? Positive L, negative L. So that's -1, 0, and 1. Okay, so 3 orientations means I can have 3 of that 5p orbitals. Okay, each orbital, how many electrons I can put over there? Maximum is 2, right? Okay, so how many electrons in total? Should be 6, right? Okay, but the question is saying it can be only 2, so that's wrong. Okay, so that's C. C saying there are 6 orbitals in total when n equals 3. We know the shortcut, right? When n equals 3, the total number of the total number of orbitals can find on that is n squared. Should be 9 orbitals. Okay, so if you go, I don't know how you use the shortcut, but if you understand n equals 3, we're looking at L equals to 0, 1, 2. So that's S, P, and D. S is 1, P is 3, D is 5. Okay, so you can do this calculation, also gets you to 9. Okay, so then that's for that. Okay, so then that's not right. That's wrong because it should be 9. Oh, that's not there. Sorry. Should be here. Should be 9. Okay, and the next one, the last electron added to neon should be n equals to 2 for this set of quantum number. Describing electron. Let's see, is that going to be true? Let's come up with our own answer. That's my job. Okay, so for neon, you're going to go to your periodic table. 10 electrons. How are we going to assign them? 1 has 2, 2s2, 2p6. This also requires you to know your orbital diagram, so you know exactly how we're placing each electron. Okay, so that 2s, 2p, as we understand, will have 3 of 2p orbitals. So the way I'm going to assign electrons, 1, 1, 1 first, okay? And then I do start to pair up this one, and the last one I'm adding is the red one, okay? So for this one was for, let me do that. Okay, so for this electron, what's its quantum number? Okay, so I have to use alpha quantum number. So that's how I can describe electron, right? So that'll be n equals to 2, because on a Lagrange level. R equals to what? You go, I don't know, but look, it's p orbital. So that's matching R equals to 1. And then M sub L, we go, I don't know M sub L. Remember M sub L, that convention will go -1, 0, and 1. So that's +1. And M sub S, since it's spinning down, so it's -1/2. So now you look at your choice. That's okay, but R equals to 0 is actually describing S orbital, not the P. So then that's where one wrong. Okay, so then that's also, you know, how you figure things out. Okay, and the last one saying 1 equals to 2, M sub L to 0. There are 4 electrons with M sub L equals to 1/2. Okay, basically saying 4 electrons will have spin up. Okay, so now you go, how do I do that? Okay, so then let's work that out too. Okay, so now we're looking at working out E. Okay, so when n equals to 2, M sub L equals to 0. You go, why can I have this situation? Let's think about when n equals to 2 on the second energy level, what can we have? Now it goes to 0 and 1. So we can have S and P orbitals. Okay, so for S orbital, okay, let's get some more space. Okay, so for S orbital, M sub L is equals to 0. Okay, so that's good. Okay, so for that, I can have 2 electrons, right? Okay, and then for p orbital, when L equals to 1, I know I'm gonna have M sub L value as what? -1, 0, and 1. Okay, but for this question, we're looking for M sub L equals to 0. Okay, that and that. Okay, so let's draw that. So we can have, you go, oh, look, that's 4 electrons. But we have one more criteria from the question. Right? It's saying we're going to have 4 electrons with M sub S equals to 1/2. I mean, the positive 1/2. Positive 1/2 is only describing what? The spin up. Okay, so it's only 2 electrons will fulfill the criteria as the question described. Okay, so then that's for that. So then that's not 4, it's only 2. Okay, so then that's for that choice. Again, this question is very good, really testing you about understanding about quantum numbers and make sure you understand. Okay, so for question 28 is straightforward. Okay, so it's asking about, this is a very easy question, right? So quantum orbital diagram, electron configuration for ground state for nitrogen will have 7 electrons. We know 1s2, 2s2, 2p3. Okay, so, and then the thing is how we're gonna arrange the last 3. We're gonna put them in 2p orbitals, 1 in each. Okay, so and then again, when they're on the same orbital, has to be the opposite spin. So if you see the same spin is wrong, this arrangement on the p orbital that's wrong. Okay, so then that's why choice was D for that question. Okay, so then that's about for this video. Hopefully this is helpful, and thank you for listening.